Hi everyone. In this video, I'm going to be giving the Module 13 Master TA lecture and also the assignment overview for this module for CIT 247. Now, for this lecture, I'll be discussing the need for IPv6, also its design and address types, and finally routing and processes in IPv6. In addition, I'll be going over the lab document for this module. So before we begin the processes and address types, let's discuss the need for IPv6. So all non-private IPv4 addresses have been allocated. In other words, all the public ones. So solutions such as NAT and VLSM or CIDR have helped, but there are not enough IPv4 addresses to support the growing number of devices connected to the internet. So if you think about it, like internet, so this goes beyond like sub or smartphones and stuff, which is already billions of those. But if you think about Internet of Things, like your refrigerators, your ovens, your cars, and so forth, if you think about the number of devices that can now be connected to the internet, it's trillions. It could be trillions, maybe more. And that's why we need IPv6. And this address type offers many benefits over IPv4, including the following. It supports a huge number of addresses. It's 2 to the 128th power. This is estimated to be around 140 decillion. In other words, that's an extreme number of addresses. Hopefully we won't need to replace this protocol. But anyway, IPv6 has built-in security through IPsec. It also provides better for support for mobile devices. It supports multimedia QoS features, so quality of service features. It also has header improvements by removing the need to recalculate the checksum, and finally negates the need for NAT, which we'll learn about in Module 15. So let's discuss the design of IPv6 addresses. So these addresses are 128 bits or 32 hex bits. So basically, the IPv6 uses the hex decimal format instead of like binary. It uses hex. This is much larger than a typical IPv4 address, which is a 32-bit address. Um, so IPv6 addresses are comprised of 8 colon separated quartets, with each one having 4 hex digits. So this is what a typical IPv6 address looks like. You can see that it has 8 groups of 4 numbers and letters. It is in hexadecimal because the number range goes from not just 1 to 9 or 0 to 9, but also goes to 0 to the letter E. So it's numbers 1 to 9, and then after the A, B, C, D, and E, and F. So IPv6 addresses can be abbreviated, thankfully, by using the following rules. So the first thing we would do is remove leading zeros in the quartet. So if you, for example, have 2 quartets here with the first one having 3 zeros and the next one having 2 of them, this would become 2 and then 11. Now I should note that if, like for example, there's a 0 in between numbers, you cannot remove that 0. I should make that clear. Quartets with only zeros are sometimes replaced with 1 0, which we'll get to that in a minute. So the second step is consecutive quartets with only zeros can be abbreviated with 2 colons. So note that you can only abbreviate one set of quartets, or consecutive quartets of zeros. So for example, if we have this address here with a whole bunch of zeros, you see here that the second and third quartets have zeros and they're next to each other, and then the second or the fifth, sixth, and seventh quartets have zeros. So we can only remove one of these consecutive quartet sets. So right here, if you see these 2 colons, that basically represents these numbers here, these 3 quartets. We replace them with these 2 colons, abbreviate the address. We remove the leading zeros in the 4th and 8th quartets. Now notice here in FE00 we keep the zeros. We can't get rid of all zeros. If a zero is not leading, it must stay in the address. Now, however, you can't do this, where you actually let me fix that here. Where you can't abbreviate twice. You can't do this abbreviation thing twice. You can only do it once, and it's recommended you do it to the set of quartets with or the consecutive quartets with the largest number of zero strings. In other words, 2 sets of zeros here versus 3 sets of zeros here. Therefore, you would replace these here with 2 colons. Here are some IPv6 address types. This picture was taken from Cunningham's PowerPoint from this module, but anyway, there's 4 types of addresses you need to know. There's global unicast. You can recognize these by the leading quartet, which is going to be like 2000. These addresses are public. They're globally unique, and they allow communication via the internet without net. Unique local addresses start with FD00. These are pretty common. I know it says /8 here and also /7. /8 is recommended for quiz and tests in this class. But anyway, unique local addresses are private. So these are kind of like your private IPv4 addresses. They can only be used for communication inside an organization, but are not routable on the internet. Link local addresses are FE80. So there's a difference between unique local and link local. Unique local has a D in it. Link local has an E in it and also 80. Once again, these are all only communicable in a subnet. They are also used for the NDP process, which we'll get to in a minute. But anyway, these basically are pre-configured on your computer already. Finally, there's link local multicast. So FF02, that is the subnet header for these types of addresses. These are multicast addresses that stay on local subnets. They are used in the NDP process, which we'll be discussing in this class, and it'll also be in your lab document. This table here will be very important for your lab document. Please keep that in mind. Other types of IPv6 addresses include unicast, which are IP addresses assigned to a single interface for the purpose of allowing that one host to send and receive data. So pretty much, they're like unicast addresses. They're pretty much the same as unicast addresses in IPv4. These are recognizable with the global unicast prefix. So you can keep in mind that the word unicast is in the global unicast type of address. There's also multicast, which are IP addresses that represent a dynamic group of hosts for the purpose of sending packets to all current members of a group. If you look back at your table, link local multicast. These are multicast addresses. There's also anycast addresses. We don't really discuss those, but you can read this in your own time if you're interested in knowing what they are. IPv6 routing in the EUI 64 protocol. So for a router to route IPv6 packets, it must have IPv6 routing enabled and have an IPv6 address configured on its interface or interfaces. To enable IPv6 routing, you do conft and then you just type this command, IPv6 unicast routing. If you look here, my command guide, I actually include that command there for you. IPv6 addresses can either be configured manually or by using EUI.64. Now, IPv6 addresses are really long and they're easy to mess up. That's why we typically use the EUI-64 method. So this latter method requires you to use an IPv6 subnet alongside EUI-64 on the router. So to add an address, you can do the conft command, select an interface, use the IPv6 command, then adder, then you type in the subnet of the IPv6 subnet with its mask, and then EUI64. Now, the last 64 mask is typically what we use in networks for IPv6, so you don't have to worry too much about subnetting. At least not until you get to the CIT 447, which even there it's not that complicated. But anyway, if you look at your lab documents, you already have this subnet here. You'll need to use this in your commands on the router. Also, be sure to include the EUI-64 key or argument in this command. So this method then automatically creates a new IPv6 address for the router interface by using a specific process, which we'll discuss in the next slide. But note that we include the subnet ID here, and this process uses that to make a new address in that subnet. So now let's discuss the EUI-64 address creation process. So IPv6 addresses are divided into a prefix and interface ID. Similar to IPv4, forgive me for that, IPv4 subnet IDs, and then your addresses within those subnets. So EUI-64 process works by, the EUI-64 process then works with the router's MAC address to create the interface ID with the following process. This process also works on your computer as well. But anyway, the first step is to split the 12 hex digit MAC address into two 6 hex digit halves. So basically it splits your MAC address into half. It then inserts this string here in between it. So FFFE goes in between the two halves of your MAC address. Then the seventh bit of the interface ID is inverted. So you don't really need to know this. You don't really need to know this for your lab, but if you're interested in learning how it works, the pages 561 and 562 of Volume 1 in your textbook explain how this process works. So you have I provided a table here. So this EUI-64 process works on this part of the address. So this part is just your subnet ID. This part here is the part that has your MAC address, the FFFE part, and then the inverted 7th bit. If you want to include how this process works in your answer in your lab document, again, pages 561 and 562 of Volume 1 in your textbook will be a great resource. Finally, let's discuss the NDP and SLACC protocol, or SLAC protocols. So IPv6 uses NDP, or the Network Discovery Protocol, as a replacement of ARP. NDP can be used by computers that use stateless address auto configuration, or SLAC, to dynamically receive IPv6 addresses from a router. This process replaces DHCP. That is a little hint for your lab. So the following steps are used in this process. So first, a computer uses NDP and its link local address, which will start with FE80, to send a router solicitation or RS message to its default gateway, which is the router. These messages are sent as multicast packets. The router then receives the RS message and responds by sending a router advertisement. These messages are also multicast packets and include the router's IPv6 prefix. The computer receives the RA message and uses the EUI-64 process to create a new IPv6 address, which will most likely be a unique local address which starts with FD00. So this is a good hint for your lab. But anyway, with that said and done, I'm going to take a brief look at the command guide. I'm not going to do a live demonstration of IPv6 because IPv6 is really easy to implement. It's very similar to what you've been doing. All you really need to do is type this command in, and then take this command here and configure IPv6 on your router, both router interfaces, and that's pretty much it. Most of this lab is just answering questions. The PowerPoint and the textbook will be very helpful for doing that. But anyway, if you want to review your commands, which you probably will in this lab, here's a few commands. Basically, the IPv6 show commands are very similar to the IPv4 ones. So for example, instead of show IP route, you have show IPv6 route. Instead of show IP interface brief, you have show IPv6 interface brief. And then if you want to see a specific interface, you have show IPv6 int and then the interface name. So this is the topology for your lab. Please make sure you use the 3725 router image. Do not use the other one because this one is the only one that will work with IPv6 in this lab. It needs to be the 3725 router. Anyway, we could probably look that up in GNS. So we're just going to create a dummy project here, but anyway, if you look here, this is the router you need to use, the C3725 image. You just need one router from here. And then if you look at your document here, you have two switches. For them, I would just recommend probably just using these. So you can just take two Ethernet switches, take your two PCs. So we do like that, like that. And then you would link these all together. That's really all there is to creating the topology. So make sure, as a review here, use let's see here, use the C3725 router, this one right here. For the switch, use the generic Ethernet switch, and then you can just use the regular PC you've been using throughout this class. So you just need the first thing you'll do is build a topology as I just showed you, except you'll be configuring the cables. And then you'll boot everything, and then on your PCs you'll just issue a show command. You can actually see your IPv6 address with the show command in your PC. So it'll actually come with one by default, and you'll need to explain what it is and how it's generated. Again, my PowerPoint explains how this process works. Also, the textbook does too. So you can use those resources to answer this question here. So enabling IPv6 multicast unicast routing, that is just this command, IPv6 unicast routing, after you do the conft command. You'll configure EUI64 on both routers. So basically what you'll be doing is using this, the way you do that is you use this. You configure static IPv6 addressing, which is going to conft, typing in the interface, and then using this command. You'll need to make sure to do a no shutdown command in the router interfaces as well. And then after that, you'll be discussing the addresses and how they were created. Again, the EUI process, 64 process, is discussed in the textbook and PowerPoint. Also, the type of IPv6 addresses, take a look at my PowerPoint here, this table, and compare that to what you see in the router, or the show command. So then you'll test your configurations. You'll just be doing some pings. And let's see. You'll just be listing the addresses, and you'll be discussing the purposes of these addresses here. And again, my table helps out with that. And just write down your ping commands that you use. Make sure you use the correct addresses that are associated with these commands here. And let's see. So also your connected routes, to see those you need to do show IPv6 route, not show IP route. Please make sure you use IPv6. So you'll be doing more pings. You'll be explaining why these pings succeed. And this is a hint here. Address types are, you need to make sure you match up the address types to what's going on. Keep in mind that link local unique local addresses cannot ping different interfaces in a router. Basically this one, link local addresses, they cannot ping interfaces in a different subnet. Please keep that in mind. And finally, why is DHCP not necessary when using the IPv6 command? You just use my PowerPoint or the textbook for that. My PowerPoint does have somewhat of an explanation, but the textbook also does as well. The textbook is really helpful for this lab. So that's pretty much it. If you have any questions about this lab or have any difficulties, please be sure to contact me. I'm happy to help you. Thank you all for watching this lecture. I hope you have a good day.